All right, welcome back. We are COMP2142. That's Game Artificial Intelligence 1 in the winter 2026 semester at Georgian, and it is week 2, part 1 of our broadcast and recording. And for this week, what we're doing is we're talking about an intro to steering behaviors. So you may not know what that is yet, and that's okay. We're also going to be talking about kinematic movement a little bit, and then we're also going to start, it says the seek algorithm today, but we're actually going to start by creating the grid, and we'll get into the seek algorithm next week. Okay, so that's what's going to happen. It's a lot to cover, believe it or not, in one course, in one class. So we're going to take it step by step. The thing that I do want to talk about is your assignment, and you've been seeing these assignments every time I talk to you in these classes. But like I said, there's 3 assignments, as if I'm a different professor every time. They're all due the same week, so Friday, January 30th. It's a lot. But again, you don't have to do in-class exercises, so that's the positive about this. So again, the idea is that we want to talk about what, just the beginning of artificial intelligence movement, so that's steering behaviors. And this assignment also does 2 things. It talks about steering behaviors and as well as a division scheme that we're gonna talk about, which is the tile grid. Okay, lots of ways to do steering behaviors, and we'll talk about that in a second. But that is the 2 things. There are a few requirements. So using the starter project. By the way, the starter project that I say, if it says starter project inside the assignment, it means the thing that I'm giving you to start with, and there is a starter project for this course that's different than the other one and different than the first one. They're all different, and there's going to be differences among all of them because you need some tools to start off with. I'm not going to start you off with nothing with some of the stuff. There's just so much to do, and for us to build up to a point where the project becomes usable, especially for AI, it takes a while. So that's why please start with a starter project. Don't start on your own. And don't do your own thing. Like, don't try and deviate and do something else. Or what's going to happen is you're going to run out of time. Not because you can't. I don't believe you can do it. I just think it's a lot for anybody or any team to do. So you're going to start with a starter project. You're going to work in groups of 2, hopefully, and you're going to demonstrate simple steering behaviors. Okay, we'll talk about what those are. You will use 2 pawns, a start pawn and a goal pawn, and I'll explain how this looks in a second. You will have a heads-up display user interface that includes buttons and sliders and stuff like that to activate and control the steering behaviors that this assignment will demonstrate. And you're going to have start pawn placement when the player moves their mouse over a grid cell and presses the S key. So there's a shortcut key, or you click the left mouse button, then the start pawn will be placed in the selected grid cell. So that's one of the things that you're going to do. And then for the, if you press the right mouse button, or you press the G key, then the goal pawn will be in the, in that cell. When either pawn is moving, what I want you to do with movement for this this particular project is I don't want smooth movement. Oh, sorry, let's go back to that. I want it to basically move from one step to the other, but I want it to transition from one cell to the other smoothly, right, across a specific time interval. So. But what I want it to do is almost like as if you're playing chess. So think about when we're going to create a grid on the screen, and what you're going to do is almost like moving your man or your piece across from one grid cell to the other. You're not going to just do one of these. Okay, that's not the point of it. It's going to be more like as if you're lifting and putting your pawn down over and over again. So we'll do a bit of a counter, if you will. Right, so some kind of interval that we're going to create. There are several algorithms that I want you to demonstrate. So the seek algorithm is the first one. It's the simplest one to do, and what it's going to do is you're going to have the start pawn, and it's going to move towards the goal pawn. Okay, so no matter where it is, it's going to move towards there. And one thing that we're going to start in the beginning is. It's going to have a specific way of moving. It's going to move and look in the direction that it's moving. And it doesn't matter where on the grid that you have the start and the goal. It's going to actually turn and move in that direction with a certain speed towards the towards the goal pawn. That's what it's going to do every single time. Okay. Flee is the opposite of seek, and what it's going to do is if you put the two pawns together, the start pawn will kind of run away or kind of go in the opposite direction of the goal pawn. That's what it's going to do. Okay, so that's the second steering behavior. The third one is going to be arrive. So when you have a seek or flee, when you're seeking, as an example, it's going to keep on going almost like in circles. That's what's going to happen. It's going to keep on seeking over and over again. But arrive, what it's going to do is going to stop you right on top of the goal pawn. It's going to just basically slow down and then just stop right there. That's what the arrive algorithm does. And those are the three algorithms that I want you guys to work on in this first assignment. So there's two assignments for steering behaviors, assignment 1A and 1B, right? And 1A is basically this this thing where you just set up these three little algorithms. These three algorithms are going to help us build everything that we need for the first half and the second half of this semester, okay? Because it's going to kind of, we're going to use some similar algorithms like this for our pathfinding project, which I'm going to give you a whole other starter, starting in the second half of semester. So that's really it. That's what I'm looking for. I know that you, again, right now at this stage, you don't really understand perhaps what I'm looking for, but there is a rubric and everything else like normal, and it talks about what I'm looking for. There is a little bit of aesthetics that you get a mark for, and that's for your user interface. So if you make your user interface nice looking, you get some marks. Okay, that's where that extra 10 marks comes from. So 70 marks for technical, 10 marks for aesthetics. What will this thing sort of look like? Okay, well, I've got kind of a completed project that I want to show you because I've gone and done the work for this one, as always. So here's the actual project structure that you'll end up completing at the end. It'll look something like this by mid-semester, and this is kind of what it's going to look like when you have your mid-semester break. You'll get this probably a project that looks like this. Okay, and if I press play, you can see that when I left click, and I can zoom in and out, when I left click, I can move my, kind of pawn around, my start pawn anywhere I want. If I right click, I can move my goal pawn anywhere I want. That's what it'll be like. And then if I press the tab key, I should be able to hide and show my user interface with the tab key. And up here, notice when the user interface is being shown, I can change the speed, the turn rate, the step delay. As an example, step delay means how long is it going to delay when you move your pawn across from one grid space to the other. These are all grid spaces. And then also, I'm just going to turn this down for a second so you don't see that. So if there's going to be several buttons, you'll be also doing something called obstacle avoidance, which is something you're going to do. And so that's kind of something that you're going to be working with. So here is your interface, and then what I'm going to do is if I click the seek button here, you can see that it's going to seek towards the goal pawn, and if I move the goal pawn around, it's going to try and seek towards that goal pawn. It'll be interactive, so anytime I move the goal pawn, it'll keep seeking towards that location over and over again, but it's going to go from one grid space to the other. So it's going to use our division scheme. Okay, so I know some people might think, well, this is way harder. I mean, I can just literally just go right towards it. You're right. That's not the exercise. The exercise is not going right towards the goal pawn. The exercise is following the grid and basically doing what you have to do to make it look as realistic as possible. So if I go here as an example, and if I decrease my speed, then what you're going to see is the circle, that it's making, it's going to get smaller and smaller. Notice that for seek, it doesn't stop. It doesn't stop moving because you're not doing arrive. Arrive is a different formula. If I go back down here, let's put it in the middle. So here it is. And if I choose flee instead of seek, so if I choose flee, then what's going to happen is, so let's just stop it for a second. If I choose flee, it's going to run away. That's what it's going to do, right? All right, let's try that again. So again, if I zoom in, you'll see that I have my goal pawn. I can bring up my, kind of like this little control, if I click seek, it's going to seek towards it, and it's going to go kind of like in these circles. Again, if I increase my speed, you can see that the circles, it's going to just increase the size of the circle, because it's going to keep going in a straight line, and it's only going to turn at a certain interval, right, towards, because it's going to go, it's going to follow something called look where you're going, where it's looking in the direction it's going. I can also change not just the speed. One thing that we're also going to be doing is changing the turn rate. So the turn rate makes a big deal. Like, for example, if I have to, if I can choose to, kind of turn quicker, then I can have smaller circles, because that's what's going to happen. It's kind of janky looking when you do that, but you're going to see that you have control over some of these, these things. So increasing my speed is going to make the circle bigger, right? But if I have a very high turn rate, it can look really janky. If I lower the turn rate down, you're going to see that it's going to start looking smoother and smoother, right? It's going to look more realistic as it's moving. And this is the kind of control that you want to initiate with the stuff in the game. So again, complete control over what you're doing in terms of, well, what's happening there. If I choose seek again, if I click the same button again, then it'll stop moving, right? And if I choose arrive instead of seek, if I click arrive, then what's going to happen is it's going to try and get to the location and stop. Now, the turn rate isn't good enough to do it, but and by the way, there's an obstacle here as well that it's having a problem with. That's why it did what it did. So I'm just going to move it over here so we don't have that issue. But notice what it's going to do. It's going to keep on kind of, turning, around and around. If I increase the turn rate and decrease the speed, it should be able to stop right on top of this planet, right? So increase the turn rate slightly, and you can see that it's going to make the circle smaller, right? There we go. And if I decrease the speed, so slow things down, it's going to get to the point where even for arrive, it's going to get right onto there and basically park itself onto the planet itself, okay? So that is, for the most part, what I'm looking for you to do for assignment 1A. I know it looks like not much. What's Tom doing? It's not that crazy. But as you'll see as we start going, the structure that you're going to have to follow is a lot more challenging than it looks. And we will talk about that today. So that's what I'm looking for assignment 1A. Questions around this before we continue? I know it's hard to ask questions when you don't really know what I'm asking yet. But as we go forward, you'll see that it becomes more clear, especially next week as we continue to add things to our algorithm. All right, I'll stop recording this one. We can always reference this video to see exactly what I'm looking for, and you can see examples of the